So what I'm asked is why it's trending now. So the first point that I posted is it came to picture is late 90s. Like, so why in late 90s came, but it is not active in 80s. So somewhere around we're not hearing the term machine learning. So some people are doing the researches now. It's predominant, like a college student doing, like most of the office, everything they want to do it in ML, AI, deep learning. So everything is coming to the picture. So the three reasons that I stated is, so huge data. So now most of the olden days we not like maintaining the data somewhere, like it's now it's like it's a electronical era, right? Like we store many of the data. So Facebook and WhatsApp, whatever you type, Google, like all your data is maintained somewhere in big data centers, like high computational power. So this one is a big and a drastic change. So I can able to remember, like past 10 years, I got a laptop which had a, like 128 MB of RAM. So I like in recent time I couldn't able to open a software in that, like it will completely hang by himself. And also I had a laptop now which has 32 GB of RAM, so which is a drastic change. So the server, like I had a server setup in my laptop. That's the computational power like we can have in us, and the storage, right? So we have a big data, like many data storages, like we can store and we can manipulate huge amount of data. So this three things that makes a machine learning to drive, and spoke about machine learning and make it alive. That's our main intention of machine learning. So that is why the machine learning is trending now. We started to speak about machine learning. We started to do some processing about machine learning. That is what. So how the machine learns huge data. I told about a huge data. Like big data is there. Like whatever you type in a Facebook is going to be a data. Like how they gonna do it. So that is what we gonna do it. Like we gonna break everything into a structured thing, and we gonna put some like filtration, we're going to feature it, we're going to model it, and we're going to say like this is what the machine learning is doing behind the scenes. So that is what I'm going to do. So um, so the artificial intelligence, machine learning, and deep learning, so all is coming under same nutshell. So if you ask somebody like what is artificial intelligence or machine learning or deep learning, so it might be a big dilemma. Like they say, like it is totally different. It is totally different. It is totally. But the conclusion is all is coming under same cell, but it has a different forms. The way of doing, right. The child can do things in a different way. Where when the child grows as a uh, some teenager, he can do the things in a different way, and when he grows like a bigger way, and he can like understand things in a different way, right? Artificial intelligence is about like the same thing. So we have to teach this everything. We have to program it. We have to give some a reason, like humans, like fuzzy logic, all these things. We have to tell everything. You have to feed everything to the artificial intelligence. So that's artificial intelligence. And artificial intelligence got some drawbacks which first for the machine learning. So machine learning is an algorithm. We need not to explicitly or what to say, hard coded the program or computation to do that. Like so it's machine learning is all about it has its own algorithms. So I'm going to feed a data. So it's going to take it by feature. So and I'm going to do some processing. We're going to do some like what to tell, like a brief explanation on machine learning, because our topic is on machine learning. So deep learning, and it's in the next level for the machine learning. So we go for deep learning. So deep learning is it's about like thinking like a human. So many, what to say, many classes, like many understanding, like many logical thinking. So machine learning will have a layers, neural nets will do a lot of things for us. So this is the entire structure of data science, like artificial intelligence, and then we came for machine learning, and then we came for deep learning. So today, like mostly we gonna see machine learning. So before machine learning, I want to say like what is AI is all about. So like AI, like it came across like 90s, like more than many years back. in AI, it's predominant, like it's detection system, right? Whatever we use in biometrics is all called to be an AI or robots, right? You used to get some. I used to do when I was in college. I used to do networking. So that's my project. Like we used to tell about AIs, where it goes and detects the weather and all those things. So that all things will come under AI. So it will have a predefined data to metrics, and it will calculate. It will tell. So signature recognition. So this is one of best example that I can go for AI. What signature recognition will do is, so example is I'm just signing something. Okay. So example, the 10 set of 10 people is there. So 10 people has a unique signature. So I can say to the AI, like it start with I, it start with dot, which end with a dot. I'm just giving the mission like this. If all this feature is okay, and you just tell this is an Isaac signature. So I'm telling that specific to Isaac. An example is specific to somebody, so and so. There are 10 people, so you can do it. So if 100 people, you can do it. 1,000 people, you can do it. Like it's an organization level, you can do it. So biometrics, everything is working that way. When it's come to a large number of people, might be Isaac Nirmal is there. So Isaac Newton is there. So Isaac Allen is there. So all the people have a high and dot, and like it's got a big confusion for the system, because we just giving some logics, right? So we giving some predefined features for it. So there is a fail of an AI, and then that's problem is mitigated using machine learning. So this is entire topic. Somebody is trying to tell something. Yeah, we are okay. Okay, if things is okay, means we can proceed. So machine learning. So today is the end-to-end goal is machine learning. So we want to spend some time on machine learning. So what is machine learning? So how machine learning works? What is how things been driven in machine learning? So how features being calculated? How like the decision boundaries is being drawn, and what are the types of techniques of machine learning? So the first thing comes to a machine learning is example. So a college student, went to an as a guy who doesn't have a minimum level of knowledge of programming. So I went to an organization. They trained me for a purpose. Okay. So the purpose is to, I can independently do some work, or I can do some task by myself. So the purpose is that for me, to fulfill the purpose of myself, they have to train me. So or else they have to do all those things. Okay. So that is an example, best example of a machine learning. So if there is human have many hands on everything, right? So they want to automate everything, or else they want to, what to say, give train a mission, like to do some information to the mission, feed some data to the mission. I tell, hey, do this and do that. If this information comes, and do this one. So this is kind of machine learning. So machine learning has its own kind of algorithms. So the algorithms plays a major role in machine learning, which learn by himself and vectorize forms, and that is all about the machine learning. So, and the other example I can tell about machine learning is a child. Okay. So example, a small child. So the child's eyes is very, they can't able to see. So in when the child is 1 month or 2 months, but the child get practice to his mother. So the child will see his mother, he'll hold his mother's arms. The child can able to understand she is a mother. Because the child spend most of his time with his mother. So the child will predict like with the other person or mother. So this is one of the good example of machine learning. So a machine doesn't know anything. So it is a layman, or like it doesn't have any knowledge on it. So the purpose of the machine learning, the data that we feed into the machine learning, it will automatically understand some things and it will predict something. So, and that is all about the basic example of machine learning. So features. So what is features? So what is features in machine learning? So in AI, I mentioned, right, the signature. Like if I is comes as a Isaac, so starting letter is I can tell that as a feature. Whatever feature I'm just giving to a machine learning. The feature, so example I'm taking is, you can able to see the features. So the user has a many characteristics. Example is, I'm going to write an application, machine learning application, to classify whether this guy is a boy or not, boy or girl. Okay. So what I'm going to do is, I'm going to, example is, I'm going to take a 100 pictures. Okay. Or else I'm going to longer, but the machine will tell like he's a girl. So obviously I failed with my machine learning. So is that a reasonable thing, right? So I told in the beginning, right, it should be a huge amount of data. So what I tell is, again I tell is, hey, check, you should have a long hair and should have a earring, and then you predict like he's a boy or a girl. Or else check with a mustache. If you have a mustache or a beard, check he's a boy or a girl. So there is a different kinds of feature I can add on, like, to the machine. Like I'm telling, like, hey, take this one, you see this one, understand this one. All these things the machine will read, and then it will classify based on the boy or a girl. This is how the machine is really is working, based on the feature. So the feature is the labels what I'm giving. Example is, a boy is having a many characteristics. He's have a long hair, he short hair, he have a beard, he have a mustache. So all this is a call to be a feature. So any doubt in features? What is feature? You got any doubts? You got understanding the feature, right? So anything like you feel like to ask me, you can stop and ask. So are you with me? Like somebody can say okay, or else we start.
Yes, yes.
Yeah, we are okay with
We
features,
understood.
right?
Yeah.
This is what features, like human being, right? So name, age, gender, so all the things is a feature or characteristics of human being. So you can eat sambar, eat biryani, fried rice. So all these things is the features. So this is the features plays a vital role in machine learning, because it takes his features, it does processing, it comes out of the data. So and the other thing that I like to point is a model. So you might have heard about models, machine learning model, like this model, that model. What is a model? So it is like a mathematical representations of data, which is inside the system. So this model will process based on vectors. So this is purely of statistics and mathematical computation things. So this is all about a model and classes, right? So I'm going to give a glimpse of classes. So I told, right, boy or a girl. So this is a binary, right? Binary is 0 and 1. And I created a example, same example I'm going to take. Like I created a model which will tell like a boy or a girl. So it will tell like whether it is a boy or a girl. Two classes, okay? So boy is a class and a girl is a class. This is a binary classification. We can tell 0 or 1. Best example I can tell is, like a mail, right? So this Google has Gmail, right? Gmail has this available feature, right? So we got many mails will coming, but certain mails will drop to a spam mail, and certain mails will come to an important mail. How that is coming? Very important mail. So the Gmail is trained himself with the algorithms. Will tell like if certain parameters or certain features comes, a tag this mail as a spam and put in the spam bucket. If this mail is coming as an advertisement, which is come with some codes or some information, just put it in the normal advertisement, means a normal message inbox. And very important, like some categories there. So what that very important is like person to person or specific to your mail, not a bulk mail, means you will categorize to a very important mail. So this all can be considered to be a class. So I got a big illustration on class. So I'll be taking it forward, and I'll be telling like what is class and how the class going to be working in machine learning. And data points, like in machine learning, like we just put everything in a data points. So dimensional space, right? So 2 dimensions there, like we have 3 dimensional. We can put a data point in a room we can able to see in a 3 dimensionals any object that will be a 3 dimensional. So when it go for 4 or 5 features, example, your feature will define your dimensions. So it might be a what to say, bit complex or bit vague to understand, but this is a scenario about a machine learning. So we can uh, understand it on the 2-dimensional way. So 2-dimensional means x-axis and y-axis. We can plot a graph and we can draw a decision boundaries, and we can classify it, or we do the regression, and all these things we can do with 2-dimension. Most probably 3-dimensional is also, but in machine learning point of view, it's we just calculate things in a 2-dimensional way. That is all about a basic. All these things is a basic glimpse about machine learning. This is what I am telling about a decision boundary. So what is a decision boundary? So this is using simple vector machine linear classifier. So this is an algorithm. It's a classifier algorithm. It is a supervised learning. So what it's doing is, example I told, right? So you can able to see my mouse pointer. Okay. So this graph contains boys and girls data. Okay. So green color can be considered as a girls, or blue can be considered as a boy. So what we doing is we just drawing on a boundary. Okay. It is drawing a boundary. So this is the boundary line is the algorithms which draws a boundary line, which has a own formula based on the formula it draws a boundary, and it the decision boundary is the key part of machine learning. So everywhere it is going to be a boundaries. We draw a boundary, and it also twiddle the boundaries based on the cost function, activation function. So we can also call the algorithm called gradient descent. Okay. So what we'll do is, so I'm just drawing a boundary here. So simply, since I am not sure, like we shouldn't like this, because we have some amount of time. So we're gonna control things like, so what this decision boundary you're gonna understand is, so there is a group of people, boys and girls. We wanna classify them. We're gonna put a wall between them and say, hey, this side people are called to be a boys. This side people are called to be girls. Okay. If a new data will come, and we'll see based on the information, it will comes here. So we'll tell like he's a boy. If based on the information, something will come here, we'll tell us a girl. This is how the decision boundary and machine learning is working. So this is all about decision boundary. So any doubts or any clarification you had? So if not, we can move forward. So now we just come into it. The conclusion, or like the what to say. So this is a heading for this today's session: machine learning techniques. So till now we seen the important things. What is might be you might have heard about features, you might have not heard about models. Let's do some mathematical or decision boundary. So this is a techniques. Will follow all the steps, feature, everything that I told, right? This is all the techniques which has a machine learning. So there is a 3 types of machine learning. Okay, techniques. Okay, That is supervised learning, unsupervised learning, and reinforcement learning. So machine learning will have this kind of three things. So supervised learning will have a data input and output. What can be done is we can tell about a classification, right? The example, boy and a girl. So the boy will have so and so is going to be called as a boy. Girl will have a so and so is going to called to be as a girl. It has a input as well as the output. Okay. So this one is called to be a supervised learning. So it has an answer within itself. So we training it. So we getting data out of it with a new data. That is supervised learning. Unsupervised learning something is about it doesn't have labels. So it is clustering, right? Group of people who have corona, group of people doesn't have a corona. We can take that one. So group of people having cough and cold, group of people only having cough, not having cold, or having fever, not having any cold. We can categorize them. So that we can come call as unsupervised learning. So supervised learning. So I want you all to to listen carefully. So the examples I'm going to give, because I'm having a question at the end of this supervising and unsupervising done. So I want somebody to answer. So I want you all to listen. Okay. So okay, classification. So supervised learning, right? So it has a two steps. One is classification and a regression. I told, right? Supervised learning is about I'm giving input data. What to say? A person having all this information. So example is burger. Okay. So burger should be in. It should have a bun. It should have a patty inside it. It should have a. It should have some veggies inside it. It should have some cheese layer inside it. So all this information, I will give some label as the burger. In pizza, it should be in flat inside. It should be round in shape. It should have some cheese on the top of it. So what to say? It will be bigger size than the burger. So all these things I will put the features and just give us the label as a pizza. Okay. So I have a data set which has many features. The feature is to tell like for burger, all this information is here, and the label is burger. So for pizza, all the information features of pizza is there. So its size will be it all this information. It got cheese, all these things. It will has a label as a pizza. Okay. So what we doing is, so in this previous things we seen, right? Same thing we want to do. So SVM. This graph is for what to say? It's a supervised learning. So the machine will take all the features. So it will come feature after feature. It will take a first feature like the size, and it check with the bun it is a bun or not, and it will check it as a cheese or not. It will check it as a patty or not. All these things will check, and it will also see the label. It is a burger or pizza. So based on the information, it will draw a boundary and will classify it. So this is how the classification is done. Classification is based on this. This is a simple example of a classification. We can tell is a boy or girl. We can tell it's a pizza or a burger. We can tell it is a child or an adult. We can tell it's a male or female. So this is a classifying. We can tell he is passed the exam or failed the exam. So this is a classification on predefined data. Okay. So this is a classification. There are many examples with the algorithms is there. So simple vector mission is most used algorithm in it's in many scenarios. The SVM is used. Naive is one of also a good algorithm. Decision tree will trace everything for you. So from the top to the end, what all happening, how the things is getting splitted, the decision tree will tell. It has its own pros and cons. SVM. Why I'm stressing about SVM is most predominantly used supervising learning algorithm in machine learning. It can take n-dimensional as well as multi-dimensional array can be possible in machine learning. Okay. And then regression. So regression is all about predicting. So the data set is same. Okay. Sorry. Sorry, somebody is speaking. So any doubts?
Fine.
Yes, I think like somebody is asking something, right? If not, like we can move forward, right?
Okay, we can proceed now, Isaac.
Yeah. If not, means we can move forward. Okay, the regression is something like what to say. It's not about classification, this or that. The example is when Corona will get over, we don't have any data. Right? So the data that we have is, so some countries the Corona has got over, like in New Zealand, we can able to see in many countries the Corona got shut down. In China also, like previous time, like it got shut down. So like all the data I'm collecting. So what I'm doing is I'm going to predict some information. So it is a prediction that we can call as a regression. So how can I predict some information? I can say like I can draw a decision boundary in between, okay, based on the data that I got. This is not like a classification, whether a burger or a pizza, whether this or that. So I can tell if 100% people, 1,000 people got affected in Corona in this time. So this is the time period that the country can be free from Corona. So New Zealand, they got 20 or 30% people got affected in Corona, and over a period of time they got recovered, right? So kind of analysis I'm going to do with regression. I got all this information with the country got recovered, right? If China got 4,000 people of Corona, they took more than 40 to 50 2 to 4 months to get recovered. So if India got like more than like is reaching more than 2.5 lakhs, I think. If that's a scenario, it will take based on the decision tree. So example is I couldn't able to draw something like example. Imagine x-axis, y-axis, okay. So in x-axis, you got a time period. So month or year, you can say month you can take, okay. So this is a month, month 1, month 2, month 3, month 3, month 4, month 5, month 6, okay. Here is a patient. Y-axis contain a patient, which has a number of patients. So 1,000 patient, 2,000 patient. We got 10,000 patient, and then we go to 1 lakh patient, 2 lakh patient. So we got all the data from all the countries got recovered from Corona. So we got a decision boundary. Whatever the line we draw, our algorithms will draw. And then what we got to do is, if we got so no country is so New Zealand or China, not even they came across 2 lakhs people, right? So we came across 2 lakhs people. We're not having a data, but we can regression. We can use the regression. We get our data. So the decision boundary is drawn from the y-axis to the decision boundary. We draw a straight line. From the straight line, we can calculate the month. So this is we got 2 data. Out of 2 data, with the data, the decision boundary is drawn. With the decision boundary to the number of patient, we can predict the number of months for India to get out of Corona. This is can be one of the best example that I can do it. Or else other use case that recently it's happening in my offices. So right, insurance companies, right? The insurance company, what to say, uh, they will format a insurance, okay. They will claim insurance. I got so and so kind of accident or medication for this much of amount. Like I'm just raising a insurance claims. I'm claiming insurance. So based on the data, I can tell. So it takes this much uh, time period to get my claim. It takes more than 3 months to get my claim. So usually people used to predict, right? So that is a kind of algorithms that use like linear regression, logistic regression. Linear regression, it's only will do a regression. Whereas in logistic regression, we got like classification. It also do a classification. So I did some sample programming on logistic regression. So by the end of this session, so I'll be demoing it. So that is all about a classification and regression. So any doubts till that? So am I like explaining it in an understandable way, or like you can stop me and just get to it to me, like we can get clarified. So we are good, right? So supervised learning, classification, regression. So it is understandable. Somebody can speak over.
Yes, sir.
Yeah, thank you so much. Your name, good name?
Madan.
Madan, thank you, Madan. So you understand
Thank you.
classification, regression. So next is unsupervised learning. So now I'm just this is going to be blank, right? So we got a data. So we got to process the data, which is labeled data, right? We got all the features and everything is fine. So we did some operation, we found it. So that is supervised. Unsupervised learning is something is totally different. So it is like what to say? Doesn't have a labels. Example is um, speech, right? So example is if a mother has spoke, I has spoke. Okay, this is the example I got. So how can you understand that Madan voice is this, my voice is this? This is one of the use case. Okay, so Madan spoke to Madan voice as what to tell, like he spoke certain period of time, I spoke certain period of time. So the two different voices, so it can classify it and it can cluster it. Okay, speech recognition and synthesize. This is what we did. So 4 or 5 speaker will speak. Okay, and we'll classify each speaker. Like when first person is speaking, we can tag it as is a first person is speaking, and second person is speaking. Like his voice will be different, his accent will be different, the way he pronounce will be different, the way you address things will be different, or the pause and all these things will be different. Based on that, it will predict and it will say like he's a person 2. So it got his information, and when the person 3 comes, so he is totally different from what we do. So it will predict some label 3. So it is a person 3. So it will predict information based on the clustering. Okay, it will cluster. So we classify it there in a supervised learning. Here we gonna cluster it. So example is Amazon. Okay, we do shopping in Amazon. So everything is transactions, right? Amazon don't know what transaction is it, but they can get an audit of it. They can do some processing. So many people from the entire Amazon got like so many transactions, right? They can classify. So many people from India got this many purchases. The turnover from India is this. So many transactions is done from India in COVID time. In America, like so many transactions done from a COVID time. So like, they can do it like they can they can cluster it based on data. Without a label data, they can cluster it. So that is all about uh, clustering, unsupervised learning. Without labels, data will process. This can be the basic example of unsupervised learning. So this is the kind of learning like many application is doing. So this is speech recognition is one of the application, and we can tell like some deep learning application is also using unsupervised learning. So Amazon, banks, they're using supervised learning, unsupervised learning, because they doesn't have a label data, right? So data will come, they'll do the process, they do it. So Google, uh, when you search something in Google, it automatically come in Facebook, right? The advertisement will pop up in Facebook. Once you go into Amazon, it'll come in Amazon. How come that is happening? That is supervised learning. Only they get the raw data, doesn't have any label. But out of that label, they're doing some classification and they're doing some process. So I also got some use case for unsupervised learning, so I'll be telling it by the end of the thing. Okay. And the other thing is reinforcement learning. So this is about uh, what to say, like we can tell about a classroom session or college, right? Example, if a lecturer is taking a class, a guy without asking a permission, he just interrupt the class and comments it in the views. Okay. So the sir is telling, hey man, like, don't you have any sense to come into the class? Get out of the class. Okay. So he learned something. So what is the observation he had is, when a lecture when a when a teacher is in the class, when some class is going on, we shouldn't just like that go into the class. We should wait, or else we should ask a permission, excuse me, or can I come in, or we should request them, and then we have to move it. So next time the same person comes, so you'll learn from the previous or problem, right? So you learn from the last problem. So this time you won't straight away go inside the class. Just wait outside the class. You ask like, can I come inside the class? Can I can I join the class? Once you say yes, he'll go inside the class. So no interruption. So he learned out of the problem. That's what the example also, it learns from the previous mistakes. So the mission, like, example is, we trained a model. So I'm just giving a input, apple input. Okay, it is telling a mango. So what to tell, like, so I'm just telling that it's wrong. It is an apple. I'm just retraining the model with a more number of data. So there is a, what to say, there is a many biasing will happen. So in splitting the data, right, in machine learning terms, so if what to say, if the feature doesn't have a value, so that will be overweighted, so it will unfit your model. So that is also a big problem will happen. Example is, I did one scenario in my office. Okay. The sentence will come, we have to identify a name in the sentence. If the sentence has a name, I have to tell that the sentence is contains name as a label. If not, I should tell that is non no name. Okay. Two labels I have. This is kind of a classifier algorithm. So we use SVM. Okay. SVM naive bias we use. So what happens is, this is a NLP kind of process which contains machine learning. So we processing the text. So name is a label. So name and a colon attached to the name and colon, the machine couldn't able to understand. So the name and a colon is a, it considered as a new word. So it couldn't understand. But my logical thing can understand this sentence contain a string called name. So what I did is, I retrained the model with a colon. Hey, if colon also come, you can also take that sentence as a name. Okay, this is can be a best example. That is, I did in a uh, in the industry. So this use case, this is called be reinforcement learning. Whenever it is not happening, but my logic will tell like this is a name. It contains a name, but whatever, go and learn, like learn yourself. This is going to be a name. Whenever sentence again will come with a name attached to the colon, it will tell like, hey, this is a name. So it will learn by himself. That is what happened. So I noticed some problem, right? So I'm telling like, hey, no, it's not a mango, man. It's an apple. Learn from this thing. So it will notice. The system will notice. Again, I'm just giving the input as an apple. It will tell an apple. So this is what all about the reinforcement learning. So this is a three techniques, very important techniques of machine learning. So supervisory, non-supervisory, and a reinforcement learning. So any doubts? So any doubts? Yeah, somebody can come forward. Somebody can, if no, like I want to like some acknowledgement, like any doubts you got. Any students can come forward, right? Or just like anybody, somebody. Yeah, I can able to see somebody. Okay. Yeah, come. somebody saying something. So is that understandable? Like you got some idea, right? Like, I know like it's a vast and it is like what to say, vague. Even I came across this all these topics, but something you got some basic knowledge about this thing. Somebody can come and address it because I got some question after this. Is that okay? We are good. Okay, it's fine. Like, nobody's turned up. So I got a question for this. Okay, question. So I want somebody to really to answer. I don't like you people to keep quiet or to stay behind. Like I want somebody to answer. Okay. So the first scenario is Facebook recognize your friend in a picture from an album. Okay, tagged photo. You might have used Facebook, right? Everybody in Facebook. Once you open the picture, right? You insert the picture. You just uploading a picture. Every face is coming, right? Every face is coming. You can your friends. Every box is coming. You can tag your friend like this. You're gonna understand what kind of technique is this, supervised or unsupervised. In other scenarios, analyze the bank data from the suspicious looking transaction and flag the fraud transaction. So two scenarios, right? You wanna like say like this first one is supervised learning.
First one is supervised, second one is unsupervised.
Yeah, who's that?
Sayyid Ibrahim, sir.
Okay, sir. Thank you.
Classification, because it is grouping, first one.
Yeah. Yeah, first one is supervised learning because
Yeah.
I told, right? Yeah.
Yeah, labeled data.
Yeah, labeled, right? You're like just a round of applause for the person who just answered. Like labeled data. It has a previous data. Your photos is n number is there with the Facebook. Your history is there with the Facebook. You can easily will tell like who you are, like what you do, all these things. Okay. In bank statement, right? There n number of transactions will come. You will not know like if it's fraud or not fraud. Okay. What you have to do is you have to understand like if this is kind of scenario, you have to do this one. Like you have to understand out of it. So this is a scenario. Hopefully, I'm just glad like I just conveyed us something. I'm so happy to get an answer from somebody like some student. I think he's a lecturer, right?
Yeah.
He's a professor.
Yeah, professor. Thank you, professor.
Dr. Sayyid.
Thank you.
Okay. Yeah, thank you, sir. Thank you, sir.
Somebody, some student, like you got some idea at least, yes or no. Don't be feel shy like I'm your senior. That's
Students who are learning, it's a part of learning. If anything wrong, that's not an issue.
Yeah, you can like might be many doubts will be there. Like we're not having some time to clarify that one, but we can come and tell like this one is what we predict. Might be you're wrong. Might be I also came across the same scenarios. Might be I can tell the scenario 2 might be transaction because I see some flag is there. Might be it will labeled something is first one I couldn't able to understand something. Might be you can tell something, right? So it will like to get you more knowledge. If you ask something, I can answer you back so that you can get some more idea. Somebody can learn out of you. So that is our intention. If not, like we can go forward. Okay, we are good now. It's okay. Use cases, right? So many use cases is there. I just put a dot by the end of Tesla, okay? Because many use cases I can't able to elaborate all these things by the short period of time. Even I just cut shorting all the important things and algorithms and stuff and decision boundaries, just like that I'm telling. So first one is Netflix recommendation system. Everybody has gone through. Say, everybody gone through Netflix, right? So we are in home quarantine for more than 3 months. So it's going to be other month. Might be you use like the data is telling the count telling the people of using Netflix and Amazon Prime is increased drastically in India. So the Netflix will a row will come and show. What it will show is some movie you watched. Example is I watched an Air Force One. Okay, so Air Force One, it comes. Some example is 2010 Air Force One movie came, and related like it is like an what is a genre? It is in a government plane genre. It might be a thriller genre. And when I see my recommended list, same kind of movie, okay, it will comes there pop-ups. How that is happening? Is that a magic happening behind the Netflix recommendation system, or any algorithms is working, or what kind of things they're doing? So I also have a question, because might be they like day by day they just getting themselves refined, like all the things like Facebook, Amazon, Netflix, Amazon, this Tesla. Day by day they're doing some process because the huge data they have, right? So what the Netflix will do is two things. First things they will do is you put some likes, right? Some movies. So I like some Tamil movie. I like some comedy movie. I like some, what to say, I like some slow movie or love movie. So all this movie I just putting click on like 5 star or like thumbs up. All those things I'm doing. So they will get some data. So it is supervised. Okay, they will label me. Hey, okay, this guy like all these movies, and then what they do is they'll see like what all the movies I've watched. Okay, and there are many persons, right? So with the same characters, they also like some kind of movies. They also like some kind of the same way you also like same kind of genre, same kind of taste. It's like Indians, right? We Indians know, right? If we had a small 2 rupees chocolate, if the chocolate is super, means we go and tell like, why can't you try the chocolate for 2 rupees chocolate? That was very awesome, the canteen, the new ice cream is there, like very awesome. Like we'll recommend, right? So we'll go and tell like people like, so it all taste. If one person buys some new product in my house, means the neighboring person will come and see, and the next second day or third day you also try to get that product. So this is what the taste and the human like nature, right? So based on the things, they will see like what equivalent this person and that person has, what he watched, what he went next, what movies he watched with the same genre. So you'll put all the things in a recommended. So Netflix is a very, what to say, very successful person. They got a huge number of users, millions of trillions of users been in Netflix. So that is a success of Netflix to me. Amazon, right? In Amazon also, right? Once you search for some product, and then you just came back, not what to say, not buying it. And tomorrow when you just log into Amazon, that product offer will be coming in the first screen. Okay, so this is also a kind of reading yourself. So this is also kind of a super machine learning thing. So it'll get your data, so it'll process your recommended data, and it'll give Tesla, right? So Tesla is, nobody might have not aware of Tesla. So Tesla is one of the leading car industry. The reports still like it, even like Toyota brought back because of Tesla. So Tesla is the number one car company in the world. Okay. Yeah, somebody's answering. Somebody's asking something. Okay, so Tesla, like they have a autopilot, right? So what they do is they doesn't have a, what to say, kind of they don't take the data as an input, but when a driver drives, right? So it is a kind of it will learn by himself. When a driver drives, based on the cameras is inside before the thing, what the driver is taking decision. When the red light is there, what kind of decision is taking. There is the statistics tells more than like, what to say, 7 trillions or billions of data has been stored in the cloud for Tesla. So they've been adding on every time. That is the huge and vast experience uh, for Tesla. So that is the future, right? So really, it is an awesome invention about a Tesla, and I think like we running short of time. I think like I want to tell something. So this is deep learning, okay? Deep learning. So I tell, right, in 2-dimensional only we can do in machine learning. So some problem in AI we came for machine learning. In 2-dimensional only, we 2-dimensional, 3-dimensional, and multi-dimensional classes means there is a big problem in machine learning. So multi-dimensional classes we can go for deep learning. So a person came and thought like, why can't we think like a human? So that's where the neural nets came. ANN came, CNN came, RNN. ANN is like what to say, the numerical processing data, classification, everything you can done with ANN. And CNN is it is a continuous values. So sorry, discrete values. Whatever the images, everything we can do process with the CNN. So RNN is something is discrete values. You can take a video. I did on application with the RNN. So it is TensorFlow. Okay, I just trained my model. I just train my model. I just see like a camera. Just get the camera to that. The model has camera information. Whenever some suspicious information is detected, it alarms me. Hey, something is happening, man. Like have a notice of it. So it is implemented in a TVS. This is a use case. It's TVS. They're using this application, which was developed by my team. So this is what example. Future is all about deep learning. So many research is going on deep learning. So many things, but running short of time, we couldn't able to do it. If possibly, if time permits, next time we'll go deep into deep learning. So we just have a huge of what to say use cases happening around. And the demo like I got to show is the Python. Like I'm into Python. Like in any scenarios, I can take some other 5 minutes extra time so that I can show the demo in a short way. Okay, Python is very familiar with the machine learning. So they got a package called sklearn, okay, which has all the models inbuilt in okay, whatever algorithms, right? Whatever I say, supervised learning, unsupervised learning, all the information they got it in sklearn. There's a library in Python, so they can do it. The sklearn will do all the work for you. Pandas is and it will do this data processing thing. Okay, so today I'm going to show some example on logistic regression. How logistic regression is. Why I took logistic regression is it will also do regression, also do the classification. Okay, that is the main intention. I think some 6 chats is there. Okay, so we go forward. So okay, so what I'm doing is, this is my Jupyter notebook. So which has a Python 3 inside it. Okay, so what I'm doing is import pandas as a PD. So I'm just giving some alias name as a PD. Okay, that one is done. So pandas, I'm just inserting it. sklearn, I told, right, this is a library has all kind of information. So I'm just importing the packages. Model selection. So model selection trained is, this is a variable we using behind the some cells. So I'm just importing it. So what this information is doing it, this is a label, right? This is a supervised learning. So you can able to see, right, this is my data. I told, right, label. What I'm going to tell is if a person is diabetes or not. Okay, if a pregnant, permanent glucose, BP, skins, insulins, BMI, pedigree, age, and label. So I'm telling all these feature. Just a mission. Let's look into it. So if this pigment is 1, glucose is 85, BP is 66, skin is 29. Like all these things, information is this, and label as 0. If a new thing is come with all the information, it will label as a 0. Okay. Likewise, if all these things present as this one, it will label as a 1. It is a binary kind of a binary classification. Tell 0 or 1 is if all these things information will come under this kind of category. This kind of category, it will tell as a diabetes. If it falls under 85 or 80, 66 or 29, it will come under like non-diabetes. Okay. So what I did is read CSV. There is a CSV file. That is my data set. Okay. I'm just putting in a pandas data frame. I'm just giving a value as a PIMA. Okay. What I'm doing is I'm just getting the from the first row. Okay, first row till the end. I'm just doing the list operation, and I'm just giving the head. So it will give you the five values of top to top five values will give. So that is what you are seeing. Okay, and then I'm just displaying the features. So the labels can be considered as a features. What are the label is there? Is a feature. This is a characteristics of the data set. So the machine takes all these things as a feature. So this one I'm just giving for displaying all these things. So I'm just taking the size. The data set contains 6,933 records. Okay. So what I'm doing is feature. I'm just telling all these features instead of labels. Consider everything as a feature, and here I'm just getting the original features, which labels also will be coming under it. So I'm just pointing X and a Y. Okay. Once it's done, I'm just splitting as a test and a train. In machine learning, always there will be a test and train. What we'll do is proposition 70 and 30. So what we'll do is 70% of data will do the process for the models. Okay, 70% of data is done. We just give that 30% of test data, right? We separated test data. Okay, we just giving fit into that model, and then the model will understand like all these things is correct or not. The model is predicting in the right way or not. This is what I'm doing. So I got 100% of data. So here I'm telling like 20%, which means 80 and 20 proposition is taking. So test data is 20. Okay, what I'm telling is 70% of data, 80% of data will go for training, and 20% of data will go for testing. So X train, X test, Y train, Y test. Okay, two variables there, X and Y. Okay, I'm just getting this using above. We just imported this model, right? This what is it, class. Okay, train set splits. So this function will splits u X train, X text, Y train, and Y test. Okay, then we are fine. So in logistic regression, right? So in logistic regression is a sklearn. In the package itself, we having this kind of the class. So what we'll do is it has all the functionality of a logistic regression. So we just assigning that to an variable, and what we do is we have to fit that variable. I told right, we have to give that 70% of data. 70% of data as a trained data. So I'm just giving the trained data and telling the machine, hey, just fit yourself and learn. Okay. So it learning, it is predicting. So it's predicting itself. So what I'm telling it again is here. Okay. So what I'm telling again is X test. Okay. X test is new data. So machine doesn't know the 30 data. Okay. The machine will only know all this data. Like 70 data is only the machine. It's overfit himself. Example is the boy will eat, the boy will not eat. Okay. The boy will sleep if the thing will come means it won't predict. Okay, that also what to say part of a mission, but it won't predict. So it is overfit himself. Only eat, only sleep. He won't place, he won't do anything. What I'm telling is I'm just feeding that extra 30 data. Okay, to that specific predict model. So why predict? And I'm doing some confusion matrix. It is like what to say, that is a kind of algorithm. The matrix it has, okay, false positive, false negative. So it might be overfit or not overfit. So the recall and precision will tell you the correct score. Okay, so might be uh, some values might be empty, some values might be some data will be there. It might be overfit, it might be unfit. So if all these things is there, the confusion matrix will tell you like false positive, false negative. Okay, false with this conclusion will tell like what is your accuracy. So out of these things, my accuracy is 81% with the logistic regression. So I just developed a model which got 70% of trained data. So 80% of trained data, you just learn from that data input I gave. Also I just gave 30% of test, 20% of test data. Also it understand the information, and then it tells like okay, it can able to understand till 80%. So we are good. Like So there are many models who can give us 90 or 90. For 80 is a reasonable thing. Above 80, 85 is a reasonable thing. So this is a small demo I just gave for unsupervised learning. This is logistics regression. This is a data set. Might be wondering what is a data set, what is a feature. This is the data set. All these things is a feature. So this is a model, right? Here see, this is a model. So logistic regression, right? So this is algorithm. I'm telling as a model. I'm just giving two binary data. This can be like I'm just doing some vectorized form. I'm just giving that information to this model, and the model will predict with the remaining 20% of data. So once it's came across with that y predict, right? Y test, y predict. I'm just telling like confusion matrix. So this is all about machine learning.
Hi learners, please subscribe to my channel and also press bell icon for latest video updates. Please do not forget to like, comment and share. Thank you.